Hello guys, welcome back to the course. In this video, we are going to do epidemiological modeling. So we're going to pick one random disease from one county and we're going to do a full detailed analysis on that one particular disease using SIR model. So if you remember in the previous video, we already learned how to calculate infectious disease transmissions using SIR model, right? So we're going to implement this concept. Okay, so now let's get started guys. Let's add another block of code. And as usual, we're just going to display the first 5 rows of the data set. So I'm going to type in data.head like this, and I'm going to hit compile. Okay, so now let's add another block of code. We are going to filter the data for California and amoebiasis, right? So I'm going to create a variable called county data like this. And we are going to assign value to this variable. So we're going to have data. And inside this bracket, we are going to have county. So I'm going to copy and paste this column name. And I'm going to put it inside this bracket. And we are going to have equals California. Because we want to make sure that we only include data from California, alright? Okay, so the next thing that we're going to have is disease. So we're going to have data, and inside this bracket we are going to have disease. So just copy and paste this column name and we're going to put it inside this bracket, all right? And we are going to have equals amoebiasis, right? Because we want to make sure that we only include data for this particular disease, because we're going to be concentrating on these disease for this epidemiological modeling, all right? And down here, we are going to sort the values. So just type in county data again. So we're going to have county data.sort values. So just copy and paste this, .sort values. And we're going to sort the values by the year, right? So just type in by year like this, okay? We're going to sort the values based on this column, year, right? Okay, so now I'm going to hit compile. Okay, it works. Let's add another block of code, and this time we're going to build the SIR model. So if you forgot the equations, just go to slide 6. So this is the equations that we are going to use, all right? So we're going to implement these concepts. Okay, so let's get started, guys. We are going to create a functions. So the name of the function is going to be SIR model. And this function is going to take 4 parameters. The first one is going to be t. So t represents the time. And the second one is going to be y, which represents the state variable of this epidemiological modeling. The third one is going to be beta, which represents the transmission rate or the infection rate of this disease. And the fourth one is gamma, which represents the recovery rate. Okay, so down here we are going to create 3 variables. So the first one is S, the second one is I, and the third one is R. So S means susceptible, I means infections, and R means recovered. And we're going to set this to be equals to Y, right? Okay, so down here we are going to do the calculations. So the first one, we are going to calculate ds dt. So if you remember, ds dt equals to negative beta multiplied by I multiplied by S. So we're going to implement these concepts to the code, guys. Okay, so ds dt is going to be equals to negative beta multiplied by S multiplied by I. And now we're going to calculate di dt, right? So it's going to be beta multiplied by S multiplied by I subtracted by gamma multiplied by I. And we are going to calculate dr dt. So dr dt is going to be equals to gamma multiplied by I, right? And don't forget, we are going to return these three values. All right, so just type in returned, and inside this bracket we are going to have dsdt, comma didt, comma drdt. All right, so just copy and paste that. Just a quick reminder. So S means susceptible, I means infected, and R means recovered. All right. Okay, so now we're done with these functions. So I'm just going to compile it. So I'm going to hit compile, and we're going to add another block of code. So this time we are going to create the parameters. Okay, so first we're going to have beta. So this is like the transmission rate. So in this epidemiological modeling case, we're going to assume that the beta is 0.2. And down here, we are going to create another variable. It's going to be gamma. So gamma represents the recovery rate. As you guys can see on these data sets, we don't have any data related to recovery rate. So we're just going to assume that the recovery rate is 0.1. And down here, we are going to create a list. So it's going to be called initial conditions. So basically, we're going to set initial values for S, I, and R. Okay, so for S, it's going to be 1. For I, it's going to be 0.01. And for R, it's going to be 0, right? So one susceptible persons, 0.01 get infected, and 0 has recovered from this disease. Okay, so now let's hit compile, and let's add another block of code. So now we're going to convert the rate to beta. We're going to assume that the rate is a proxy for transmission rate. Alright, so now we're going to copy and paste this variable. So we are going to create a new column, and the name of that column is beta. Okay, so this column represents the transmission rate. Okay, so I'm going to copy and paste county data, and inside this bracket, we're going to copy and paste this column name, rate. So in this case, we're going to assume that this column, rate, represents the transmission rate. Okay. So the next thing that we're going to do is to create another variable. It's going to be t-span. So this is time span, right? And we're going to assign value to this variable. It's going to be 0, length. So we're going to calculate the length of county data. So we're going to copy and paste this and then put it inside this parenthesis, right? So this is going to be the time span based on the data set. Okay, so let's hit compile, guys. And let's add another block of code. So this time we are going to solve the SIR model. But before that, I'm going to remind you that we will need to import this library. So just import this library first, guys, from scipy.integrate import solve IVP, right? So make sure that you imported this library first because we need that. Okay, so now let's continue. So we're going to solve the SIR model. So I'm going to create a variable called solutions, like this, solutions. And we're going to assign value to this variable. So it's going to be solve IVP. So we're using this module, guys. All right. So solve IVP. And inside this parenthesis, we're going to have SIR model. So if you remember, we already created the SIR model here. So just copy and paste that down here. And we're going to have t-span. So just copy and paste that and then put it here. And we are also going to copy and paste the initial conditions and put it inside this parenthesis. And we are going to have args. This is like another parameter. So inside this parenthesis, we're going to have two parameters. The first one is beta, which is the transmission rate or the infection rate. And the second one is gamma, which is the recovery rate. And we are also going to have t-eval. So we're going to use np.arrange. So it's going to be 0, the length of the county data. So just copy and paste this and then put it inside this parenthesis, right? And lastly, we're going to have 1, like this. Okay, so make sure that you also imported NumPy because we are using NumPy down here, guys. Okay, so now let's hit compile. Okay, it works. Now let's add another block of code and we're going to extract the result. So we're going to create a variable called t. So it's going to be solutions.t like this. And we're going to type in s, I, r. So susceptible, infections, and recovery. It's going to be solutions.y. And let's hit compile. Okay, then what we are going to do next is to plot the results. So I'm going to add another block of code and we are going to type in plt.figures. So just a quick reminder, make sure that you import matplotlib because right now we are using matplotlib, all right? So plt.figures, and inside this parenthesis, we're going to have fixed size. We're going to have 10,6. And down here, we're going to create the plot. So plt.plot like this. So we're going to have t, which is time, s, which is susceptible. And for the label, it's going to be susceptible. Okay, so we're going to do the same for infectious and recovered. So I'm just going to copy and paste this twice. And we're going to replace s with I. And we're going to replace susceptible with infectious. And we're going to replace s with r. And we're going to replace susceptible with recovered. Okay, so down here we are going to add the label. So plt.xLabel. So in this case, the x-axis or the horizontal axis is going to represent the time. So inside this parenthesis, we are going to have time. And for the y-axis, it's going to represent the proportions of populations, right? And obviously, we're going to add the title so people understand what does this plot represents. Okay, so I'm going to type in ISIR model for amoebiasis in California. And we're going to have plt.legend, plt.grid, true, and lastly plt.show. Okay, so before compiling the code, there is one mistake that we need to fix. So up here, as you guys can see, we have plt.figure. So it is supposed to be plt.figure without s. So just remove the s. Okay, so now I'm going to click compile. Okay, as you guys can see, this is the epidemiological model for amoebiasis in California. So the blue line represents susceptible, the yellow line represents the infected patients, and the green line represents patients who have recovered from this disease. Okay, so as you guys can see, the x-axis represents the time, and y-axis represents the proportions of populations, all right? So hey guys, I think that's it. That's all you need to know. That's how you do epidemiological modeling. I'll see you guys in the next video where we are going to learn how to do public health policy evaluations. I'll see you guys there.